It's an IIPMT question basing on work power energy. The question is like this. The human heart of a man pumps 5 liters of the blood through the arteries per minute at a pressure of 150 millimeter of mercury. Density of the mercury is given for you. Then what is the power of the heart is? Well, we shall remember the formula for power of anything, like any device. Power is rate of change of work done. Even heart is not different from that. So power is work done per time. But work done now here has to be, work done formula is something like F ds, force into displacement, by dt, you can say, time. But force is not a content in our problem. We have to express it in terms of pressure because pressure is given for you. So we shall remember back what's the definition of the pressure. Pressure is defined as force acting on a body per unit surface area. That implies force can be expressed as pressure into area. Substituting this, power will become, in the place of force, pressure into area into displacement by time. Area into displacement could have been volume. Area into change in the displacement is change in volume. So power into dV, be careful. This is not change in velocity, but this is change in volume by dt. Where that's what you are asked to calculate. It is given for you. dV by dt, volume per second is 5 liters per minute he has given. I have to convert that. 1 liter is 1000 cc, centimeter cube. 1000, 1 centimeter is 10 power minus 2 meter, whole cube. So 1000 into 10 power minus 6 meter cube. So 1 liter is 10 power minus 3 meter cube. I also know that 1 minute equal to 60 seconds. That implies rate of volume that is pumped by the heart per second by blood is 5. In the place of liter, I can write 10 power minus 3 meter cube. In the place of minute, meter cube per second. I got dV by dt now. Now I can calculate the power. That implies, yeah, that implies power can be written as I wrote, pressure into rate of change of volume. But how much is that pressure? He has given that pressure as 150 millimeters of Hg, mercury. But be careful. Pressure won't have a unit of millimeters of Hg. This is only the height or the length given for you. The actual formula of the pressure is HdG. H is 150 millimeter means 10 power minus 3. Density is 13.6 into 10 power 3 given for you in SI system. G is also given as 10. Then this becomes Pascal. This is how I have to calculate pressure. So knowing everything, now I can calculate the power as P means this much. 150 into 10 power minus 3 into 13.6 into 10 power 3 into 10, that is P, into dV by dt is this much. 5 into 10 power minus 3 by 60. This has to be simplified or calculated. See, 10 power minus 3 minus 3 minus 6 is there. And how much 10 power what other 10 powers are there? See, this is 10 power 1. This is 10 power 3, 10 power 4. This is one more, 10 power 5. Right? So what is the value? Then I can rearrange these terms as yes, 15 into 13.6 into, I'm writing this 10 power separately, 5 into 10 power minus 6 and 10 power plus 5. This is plus 3 plus 1 and plus 2. divided by 60. That is 15. 15 fours are 16. So that will become 13.6 into 5 by 4 into 10 power minus 1. That is 1.36 into 5 by 4. So it's very clear 5 by 4 is 1.25. This is going to be little more than 1.36. The only answer that is little more than 1.36 is 1.7. It's definitely greater than 1.5. So the answer is 1.7 watt. So your heart is a very small engine with a power of 1.7 watt. So to solve this problem, we have to know that the power is work done by time, but it has to be expressed in terms of pressure. Once if you understand that concept, writing a formula pressure is HD is a normal thing that you know. Conversion factors obviously there, 1 liter equal to 10 power minus 3 meter cube. If you know all that, then you will be able to solve that problem. Thank you for watching.